This video is episode 2 of Christopher Reads the Help Files. So in this thing, I'm going to read the workflows. So it looks like the first one is how to move data from LAN desktop. Use this workflow to help you efficiently move existing data from AutoCAD LAN desktop to Autodesk Civil 3D. Prepare for the move. A clear understanding of your current workflows and processes will help you implement Civil 3D successfully and be better able to validate results. I guess that's true, but then Civil 3D changes all of your workflows. So I'm not quite sure how that helps you. Map or set up styles and settings. Styles control the appearance and sometimes the behavior of Autodesk Civil 3D objects. By using styles in Autodesk Civil 3D, you have great flexibility in the presentation of design elements, including labels and tables. Migrate the LAN desktop data. There are various tools and methods for moving LAN desktop data into Civil 3D. I guess that's true. All right, the alignments workflow. Refer to this section for high-level descriptions of tasks you perform when creating, designing, and finishing alignments in Autodesk Civil 3D. Topics in this section. Workflow to set up alignments. Establish different alignment and label styles for each design phase. It kind of should be design phase and type of work. All objects have a default style that you can copy, edit, and then save with a new name. You may begin by establishing styles for different design phases. For example, design styles might have details that would not be necessarily in plotting styles. Set up alignment styles. Alignment styles control the visual display of each alignment component. I mean, this should also indicate view directions, such as model, section, profile, etc. Oh, I'm out of room. It's horrible. Alignment sets control the label styles that are applied to the individual elements that you want to label on the alignment. Set up the design criteria file. The design criteria file contains minimum local standards tables for design, speed, radius, and length of individual alignment subentities. It's not really true, because it looks up the design speed and then it tells you what the radius and length of the value should be. But I'm out of room. Dang it. See if it'll let me come back in and nope. I guess they don't want all my feedback. Set up design checks and design check sets. Design checks verify design criteria for parameters that are not included in the design criteria file. Workflow to design and edit alignments. Create alignments by layout from polylines, from pipe networks, and from LAN XML data. Create alignments. There are many more methods now, such as creating from corridor. Edit alignment, fix floating or free entities. Use the constraint-based commands on the Alignment Layout Tools toolbar to add a fixed entity, a free entity, or a floating entity. Lines, curves, spirals, curve, spiral groups, and spirals to the alignment. Edit alignment numeric parameters values. Use the Alignment Entities Vista and Alignment Layout Parameters dialog box to display and edit parameters of alignment entities that are part of the solved alignment geometry. It's kind of hard to know where they are. Maybe there's a picture. Nope. So I would find this really hard to find as a user. Looks like it killed my, hopefully it submitted it. Edit the alignment using grips. Use grips to change the vertical curves and tangents in alignment graphically. What about my spirals? Add final labels to the alignment. Use the alignment and table styles to control the appearance and behavior of alignment labels and tables. Assign a style for viewing and plotting. Use alignment styles to control the visual display of each alignment component. Create plan profile sheets for plotting. Use plan production tools to quickly create construction documents from drawing. I think quickly is overstating all the work that you have to go in to create that, especially if you have like alignments where you have like a short segment and then a longer one, and you want to take the end of the longer one and have it on the same page as the shorter one. I mean, that takes a lot of work because Civil 3D doesn't think you should be able to reduce the number of sheets. It says you got to use the max, a lot of sheets instead of providing tools to quickly combine alignments if they don't quite take up the entire sheet size. Kant workflows. Refer to this section for high-level descriptions of tasks you might perform when working with Kant in Autodesk Civil 3D. Workflow to set up default rail parameters. Customize the design criteria file. Update the design criteria file that ships with Autodesk Civil 3D, or create a new file that contains your local standards tables. Verify the default label abbreviations. Update the abbreviations in the drawing settings to use the critical point text that is required by your local agency. Verify alignment feature settings. Review the alignment feature settings for Kant options and rail alignment options, including default track width. Specify the unit chord length or unit arc length. Use the degree of curvature ambient settings to specify the value from which degree of curvature is calculated. I don't know, that seems like a lot of work. Almost feels like it should be its own one single dialog box instead of having to go to 4 different locations. To calculate Kant along a rail alignment, create a rail alignment. Create an alignment with the standard alignment creation tools, making sure to set the alignment type to rail. Specify design speeds and design criteria file. Set the design speed for each curve and verify that the design criteria file has been applied in the alignment properties. Calculate Kant. Use the Calculate Kant wizard to calculate Kant using specified criteria and tables. Should also include a sentence or paragraph on where to modify Kant. And then we have to view and edit Kant data. Edit Kant data as needed, modify the Kant criteria for each curve and adjust the calculated Kant data. Create a Kant view. Use a Kant view to visualize applied Kant on each curve. Use Kant view grips to graphically edit critical station locations and applied Kant. Add or remove critical stations. Resolve overlapping Kant curves. correct conditions in which the Kant region of one curve overlaps the Kant region of an adjacent curve. Seems like a lot of intelligence that Civil 3D doesn't have. It seems like the overlapping, we could come up with some general parameters and then have Civil 3D automatically resolve the overlap being Kant based on rules. But I guess that's just a wish to have an intelligent product. So refer to this section for high-level descriptions of tasks you perform when creating catchments and flow paths. Workflow to set up a catchment model and pipe network. The first step in setting up a catchment model is to determine the general drainage trends across the site. Shouldn't Civil 3D be doing this for me? This means identifying high points, hydraulically most distance point, low points, collection or discharge points, as well as channels and ditches. Low points are often a wetland or pond on the site or a budding property, or could be a catch basin in an adjacent road. I sure hope they don't put catch basins in adjacent roads. After this initial analysis is done, you can use the catchment, flow path, and flow segment creating commands to create the catchment data. Wow, so I got to do all the math or figure out where everything is first, and then I get to run the commands to tell Civil 3D where the catchments are. It seems like a smart person could probably set up some tools, and I think there are like Civil Geo who have done this, where the catchments are calculated for you, and then you can modify and join and have some great tools to modify them. To analyze the site's drainage patterns, use the surface properties command to do an elevation analysis, watershed analysis, and or a slope arrow analysis, and or use the water drop command to show where the water would flow across the surface. You can do multiple surface properties analysis and then draw polyround lines around the areas that represent the catchments you want to analyze. Wow. We get to manually draw it. Wow, just like I did when I first started out, using plans and taking a USGS map and hand drawing it. I mean, I guess the only benefit is that I don't have to use a preliminary to calculate the area. I get the area from AutoCAD. But I could just do this without Civil 3D, without paying Autodesk thousands of dollars for a command that doesn't really do anything other than make you do the work. Optional, based on a likely discharge point, create a pipe network with an outfall structure at that location. Okay. This step is not required in order to create a catchment, but in association with the structure is required if you want to use the catchment and flow path data in Autodesk Storm and Sanitary Analysis. See, Autodesk owns more than SSA for hydrology. Do they not matter anymore? Right? Because you have the products and you aren't including it. I guess Autodesk kind of forgot about them. In their development dollars, definitely seems like they've forgotten about it. And then the discharge point. Pipes usually water to the discharge point. And an inlet is upstream of the discharge point. So I mean, you have the pipe at the output, and then you usually have an inlet, like 3 or 4 or more pipe run lengths up there and that's where your catchments go. And then the catchment catches the water, takes it to the pipe to your discharge point. Your end of your catchment isn't at the discharge point, usually, other than your overall one. Use the create catchment from surface command for an area that is contained within the surface. The math here, or the algorithm that Civil 3D uses, isn't very intelligent. It could be better if we had like BIM objects that had asphalt pavement surfaces, we have a curb and gutter, and then we could use those surfaces to actually have a direction to the inlet. So we get the BIM objects help determine where the water should go, rather than using tin triangles to try to figure it out. Because using the surface, you have triangles that are flat, and they don't always correctly go to the low point. If you're defining an area that flows to a boundary, you may need to draw a polyline around the desired analysis area and use the create catchment from object command, such as if it abuts an adjoining property or wetland. Polylines. Polylines aren't BIM. Sure would be nice to have a BIM product. Create a flow path from a surface. You can create the flow path while using the catchment creation commands, or you can create or edit the flow paths after creating the catchments. Define the outfall reference structure. When creating the catchment, you can select the pipe network structure you created in step 2 above, or you can find this later on in the catchment properties. Seems like the inlet would be either along the flow path, like if you had a curb and the curb intersected a catchment, an inlet, you'd think that structure would automatically be added as a catchment, so you can automatically collect that water. And then if on the other end of the pipe or structure, it continued on, then you would know that some of the water is going to flow by and continue on. Or if it's in a sump condition, you would be able to have a catchment in there as well. So, I mean, this just really shows that Civil 3D isn't BIM, and it's making you do all the work rather than using the 6, 4, or 8 processors you have on your computer to do the work for you. Like, I don't get why we're spending this much money on Civil 3D when Autodesk is calling it BIM, but if it is BIM, I mean, this just shows how stupid Civil 3D is if it is a BIM product. Create additional flow segments and define segment data. The end result is calculated time of concentration, which can then be used along with the catchment area, runoff coefficient, and pipe structure outlet data in storm and sanitary analysis. Let's see. To set up the part matching settings and exporting catchments to storm sanitary analysis, I guess HydroFlow doesn't matter. Why buy it in the first place, and why not improve it and take the 2 features of SSA and HydroFlow and make one product that does what each one of them did instead of having 2 products? Just buy it and forget about it, I guess. To accommodate the large number of parts available and custom parts that may be in use, Autodesk Civil 3D employs a strategy for dealing how parts should be represented or matched for use in Autodesk storm and sanitary analysis. Decide upon your part matching strategy. Review how to set up the settings and optional XML part mapping file to control how parts are round-tripped between Autodesk Civil 3D and Autodesk storm and sanitary analysis. So just another example of Autodesk not really caring about interoperability even between their own products and products that the same team has ownership of, right? Why are they making us do this work when they should be able to figure out, hey, it started at this structure, went into SSA, it came back, which structure does it belong to? And if it went out from Civil 3D and you added a structure, it's going to have the same properties usually of another one, and it should go and grab that, or grab all of the structure data, and then in SSA, select one of the structures or parts from the Civil 3D drawing that was imported in, rather than making the users work. Because I don't want to work. I'm paying Autodesk to create a software product that I don't have to do as much work, but that doesn't seem the case in this. Another in this case. Set up the pipe network feature settings according to your part matching strategy. The settings assist in controlling part matching when moving between Autodesk Civil 3D and Storm and sanitary analysis. The last time I tried to do this workflow, it didn't work out very well because I only had like one option for each type rather than the multitude of different structures we might have on a project, such as grates, drop openings, and the like. Specify the inlet settings for the structure associated with the catchment. Specify the inlet location in the structure properties. Run the edit in storm and sanitary analysis command. Select the pipe networks that are associated with the catchments you want to export. Why do we have to go to SSA? Why not just do it in Civil 3D? To analyze and edit a catchment model in storm and sanitary analysis, use this workflow after you've exported a Civil 3D model to SSA. In SSA, double-click on the Project Options node and set the required project options. See Project Options on page 175 of the Storm and Sanitary Analysis User's Guide. We aren't even worthy of getting a link to page 175 to the help file. Looks like the SSA help file isn't even included in the Civil 3D help list. 1, specify the hydrology method. By default, the first time you bring in data from Autodesk Civil 3D, this is set to the rational method. Another link to the help file that's not part of the Civil 3D help file. Select the time of concentration method. Specify the link routing method. Hydrodynamic routing is suggested for rational methods. Set up the rainfall options for the project, either an IDF curve for rational or rain gauge for other methods. Set up the IDF curve for the rational methods, see IDF curves, or set up a rain gauge for the project. Set up required analysis options on the General tab. Define the analysis duration by modifying the end analysis on values. Choose an adequate analysis duration to cover the rainfall duration and any surface routing. On the Storm Selections tab, optionally select the storm analysis options. For example, if you set up multiple storm events for the rain gauge in step 7 above, you can select multiple storm analysis and specify the output file names for each. See this. I do not see step 7. Where was I? Multiple SSA and specify the outlet file names for each. Refine subbasins. If you're using TR55 or TR20 methodology, check the subbasin properties and set up the curve number for the soil groups for all the subbasins. Refine inlets. You may need to adjust the road and gutter specifications and grate settings in the inlets dialog box. Sure would be cool if it took the values that were in the Civil 3D model and applied those settings, or if Civil 3D had the required information to do so. The setting under roadway and gutter specifications section to help determine the gutter spread, the grate clogging factor and roadway gutter bypass link, direct the waters that is not captured by the inlet to the next inlet. The settings under combination inlet specifications will vary depending on inlet type. Perform an analysis, click the Run Analysis button, display analysis reports, create profile plots. Sure would be cool if it did that in Civil 3D so we could plot them and maybe add extra annotations. I don't quite get why we're doing that in another product. Create time series plots. Check the subbasin properties for each subbasin and review the peak runoff. The peak runoff is displayed in the analysis summary area of the physical properties tab. To import a catchment model into Civil 3D. Use this workflow after you've worked with a Civil 3D model in storm and sanitary analysis. Export your data from SSA using the HydroFlow Storm Sewers STM file format. The HydroFlow STM file is used as a data transfer file between Autodesk Civil 3D and storm and sanitary analysis. I mean, I don't get why we have two different products that are owned by the same company where we have to transfer files between them. It seems like an awesome approach would be to have it all run in one program instead of having two. And SSA was bought by Autodesk for a long time ago, so by now we should have an integrated product and feel, but I guess Autodesk just doesn't care. Import the STM file into Autodesk Civil 3D. Edits you made in the storm and sanitary analysis are preserved on import back into Civil 3D. Let's see, so my experience is that the import is imperfect. A reminder to the user that Autodesk didn't do a good job, and the user should check to make sure the structure are correct and not mapped incorrectly. So at least the user knows that they should check their work because Autodesk didn't do a very good job on it. All right, corridor modeling workflow. Refer to this section for high-level descriptions of tasks you might perform when working with corridors in Autodesk Civil 3D. To prepare the drawing for corridor creation, create drawing templates that contain standard styles and settings that will help you work more efficiently and ensure that your final drawings conform to your office standards. Open a drawing. Open an existing drawing or create a new one. Select the default settings. Use corridor settings to specify the default behavior for corridor-related commands. Create the styles. Styles control the display and design characteristics of drawing objects. Create and specify the label styles. You can define default label settings at 3 different levels. Create the quantity takeoff criteria. Use quantity takeoff settings to specify the default style and name format settings for quantity takeoff. Okay. Save the drawing as a template. By saving as a template, you can leverage the style and setting changes. Okay. To set up data for corridor creation, before you create corridors, you must have existing data, such as existing ground surfaces, alignments, profiles, and typical sections, assemblies. Okay. But before you create corridors, okay. It's just weird that they say before you create corridors, but we're doing the corridors. And then they include the steps down here. I guess that's okay. So we're going to build the existing ground surfaces. Surfaces are used to derive alignments and profiles for corridor grading. Don't know. I guess I don't get how our surfaces it doesn't quite make sense. Define horizontal alignments. Alignments are used by a corridor as its center line. Create the profiles, use existing ground profiles, and design finished grade profiles, vertical alignments. Calculate super elevation for the curves on the baseline alignment. Important, all calculations should be finalized before they are applied to the corridor model. Changes in a corridor baseline alignment are not reflected in calculations. Changing the design criteria does not update the corridor model? This is false. It's partially true. Plan the required assemblies. Before creating an assembly, identify the different types of sub-assemblies you need. Create and maintain the required assemblies. Use the sub-assemblies to build the required assemblies. This section provides the processes used to create corridors. Create a corridor. Use the create corridor or create simple corridor commands. So it's missing the rehab corridor. Modify the corridor. Make any required customizations to settings or styles for the corridor. Okay, I guess. Modify or override individual corridor stations, override corridor and assembly parameters, and apply the overrides to a station or range of stations. That's kind of dangerous. I don't like doing it. Just because if you're on a long project and you come back and it's like, why did I change this range of stations to be 2% rather than 5%? And maybe that reason isn't there. So I always suggest to add it to your assemblies, the change, and create a new assembly or add the descriptions to the sub-assemblies on why it does a certain thing. That way you have a history of what's going on. Where you do the overrides, oftentimes you find that people don't go and add the notes to the corridor properties because it's in a different location. To edit a corridor in section view, this section provides the process used to create and edit corridors in section view. Create a corridor, specify a baseline alignment and profile, but you do not create regions or specify assemblies. I don't see why not. It is incomplete because feature lines can now be used as baselines. Open the section editor. Use the section editor to view cross-sections of the corridor model while either creating or editing a corridor. But I can't because I don't have any regions. Specify other objects to display in the section editor. Specify which 3D objects you want to represent in section, navigate to a station, use the section editor tools to navigate to a corridor station. You can even view a section that is between corridor stations. Create a corridor region, drag and drop an assembly from Prospector or Tool Palette or a catalog, and then specify the targets and station range for the region. Drag and drop. Well, I got to try this. Change region assemblies as desired. Specify a new region assembly either from a list or by dragging and dropping from Prospector, a Tool Palette, or a catalog. Okay, let's try it. So I'm going to open up a tutorial drawing. You can open up the corridors. So we'll create a corridor. So we'll hit OK. And then we have the assemblies, divided highway. We go into properties. We go to parameters. And then it says I can drag and drop from tool space. So that didn't work. See if we can take the divided highway and drag it up. Nope. Let's go back to help. Use section, drag and drop an assembly from the Prospector, a Tool Palette or catalog, and then specify the targets and station range for the region. This doesn't appear to work anymore. There was like some drag and drop functionality that they took out for some reason. And maybe this is one of those cases. So I'm not quite sure what they mean by it, because I've always like right-clicked and then selected the region, but I've never seen a way to drag and drop it to add a region. Maybe I'm just missing something. So to visualize corridors, hopefully it added the feedback. To visualize corridors, after you have created a corridor, create corridor surfaces and boundaries to help visualize the corridor. Create a corridor surface. When you create a corridor surface, it is added to the surfaces collection. Create corridor boundaries. Use corridor surface boundaries to prevent triangulation outside of the daylight lines of the corridor surface. View corridor sections. You can use the View Edit Corridor Section tools to visually inspect how assemblies are applied at various stations, render a corridor boundary region, render corridor data using the AutoCAD render command. Okay. Let's see. So it's missing the step to add link or feature line data to the surface. Because right now we'll have empty surfaces because Civil 3D is stupid and doesn't intuit if it should be top or datum or what surfaces you want. You kind of have to tell it, spoon feed it what you need to do. There's really no easy button that Civil 3D has that allows you to quickly create those top and datum surfaces, even though if you have good standards like they've been talking about in the help files, you really should be able to just add the surfaces and have it automatically add a top and datum or whatever your standards are and automatically add the boundaries, right? I don't quite, for a BIM product, I would expect that basic functionality instead of making you do all the work and hit a bunch of buttons that provides no real value. Once it goes through and adds it, you should definitely be able to go back in and edit it and modify it and change it. But you should be able to have the option of it doing most of the work for you, and then you go back in and verify it. To export corridor data, after creating a corridor, you can export several types of data. Export corridor feature lines, export corridor feature lines as alignments, grading feature lines, profiles, or polylines. Export corridor points as COGO points, export all the points from a selected corridor, or constrain the selection based on station ranges or point code types. Export corridor surfaces as disconnected surfaces. Exported surfaces are no longer part of the corridor. I guess that's true. And I think I'm going to stop there for the second version of Christopher Reads the Help File. In your imagination, pretend there's a flashy screen at the beginning and the end and all that other jazz that all those other YouTubers use. I'm not that complicated. And hope you enjoyed me reading the help file.